This question, madam. The string wave equation is given by y is equals to 0.002 into sine 300 into t minus 15 into x, and mass density is mu is equals to 0.1 kg per meter. Then find the tension in the string. Then find the tension in the string. Sir, I'm giving the options: 13 Newton, 20 Newton, 40 Newton, 45 Newton. String wave equation is given by y is equals to 0.002 sine 380 minus of 15 into x. And mass density is given for me, then find the tension. Tension in the string and mass density means what is the formula beta? Wave velocity is v is equals to under root of t divided by mu. I need the tension, so square it. V square is equals to t divided by mu. So t will be equal to how much? Mu into v square. This will be the formula. I'm already having mu. I don't know v. V can be calculated by the formula. V is equals to omega by k. So what is the value of omega beta here? Omega is right now for me 300 and k value is equals to 15. So this will be equal to 20 meter per second. So tension in the string will be equal to 0.1 kg into your, this one is right now for me 20 whole square. That means 0.1 into, this is nothing but 400. 0 point means 1 by 10 into your 400. This 0 will get cancelled. So this will be equal to your 40 Newton. So the answer will be equal to 40 Newton. Clear? Sure. Let us try to understand the resonance beta. What do you mean by resonance beta? The frequency of the one object is matching with the frequency of the other one. That is will be the case of your resonance. So can I say that when one object's frequency, one object vibrating at the same natural frequency, of a second object, okay, forces that second object into vibration mode. Okay, it is making the second object to vibrate. This phenomenon is known as resonance. This phenomenon is known as resonance. Okay, what is happening here right now? Frequency of the one, when one object is vibrating at the same natural frequency as that of the second object. And it is forcing out. What is it doing right now? It forces that the second object into the vibration motion. This phenomenon is known as of your resonance. Okay. So what is the resonance beta? So when one object is vibrating at the same natural frequency as that of the second object and making the second object to get into vibration is known as of your resonance part of relation. Okay. And for this one, we are using a resonance column method experiment. I hope you everyone might have been remember that one. I'm just fastly revising it here. See, let's say for example, there is one tuning fork here right now like this, which is being opened, and one of the closed organ pipe is filled with your water like this. Okay. And I've taken a tuning fork and vibrated in this one so that a wave will go and hit like this. Isn't it? So you know that the distance between node and here the open end is anti-node. This distance will be equal to your lambda by 4. One sound is being present. And along with that one, there is certain extra wavelength. That extra wavelength, we are calling it as of your end correction E. So this one is known as what for me? Your first resonance. Okay. So in order to make it still vibrated, what we are doing is we are increasing the water column in the closed organ pipe. So when I'm increasing the water in the resonance pipe, right now by decreasing it, we get a wave vibration like this. Okay. Here it will be node, here it will be node, and here it will be your anti-node. Now from here to here, this distance will be equal to how much better? 3 lambda divided by 4. This will be equal to right now for me what? Second resonance. Or it will be your third harmonic. Third harmonic. Okay. Still, if I lower the water in the closed organ pipe, okay, and water is being filled here up to this one. And I'm taking a tuning fork, striking it, and it is producing the vibration. So that vibration is coming here right now. No doubt here we are getting right now every time an anti-node. One extra wavelength which is coming out is known as a pure end correction. So for this one, there is one wave here right now like this. There is one wave like this. And another wave touches the water, and here it touches this. So this is node, this one is node, and this one is node. So now from here to here, this distance will be equal to how much beta? 5 lambda divided by 4, because the frequency will be in the ratio of 1:3:5. So and this one is known as right now for me your third resonance. Third resonance, or it will be your fifth harmonic. Or your fifth harmonic. Okay. So now to find out the speed of the sound, we use the resonance column method. So what I'll do is, I'll write the first equation right now. The first length of this one will be equal to how much better? L1 plus end correction is equals to your lambda by 4. In second case, L2 plus E must be equal to 3 lambda divided by 4. This is equation 2. This is your equation number 1. So see from 192 what I can get? From equation 192. So if I subtract it, L2 minus of your L1 will be equal to 3 lambda by 4 minus of lambda by 4. That will be equal to your 2 lambda divided by your 4. So that will be equal to lambda by 2. So wavelength will be equal to how much for me? Lambda is equals to 2 into L2 minus L1. So like that, I got the wavelength if I'm comparing the first resonance and second resonance. The same way you can compare the first resonance and third resonance. It will be L3 minus L1 go on. How do you calculate the end correction for this one, beta? Once I know the wavelength, I can calculate the velocity. V is equals to F into your lambda. So V is equals to frequency. This one is nothing but of your 2 into your L2 minus of your L1. So speed of sound will be equal to 2 times of your frequency into your L2 minus of your L1. So this is the speed of the sound in the 2. What I did here, I am comparing 1 and 2. Tomorrow in examination, he may give between 2 and 3. He may give between 1 and 3. He may give between 2 and 6, maybe 7, like that. In the ratio of 1 is to 3 is to 5 is to 7, go on. Now, how do you calculate this end correction better? That extra distance right now for me. So I need to calculate the value of your E. So end correction can be calculated by the formula, very important formula. End correction detail going to time chappochu, but formula is more than enough to do the numericals. L1 plus of your end correction is equal to how much for me? 2 divided by your L1 plus of your E is how much better? Lambda divided by 4. Lambda value already I got. Lambda value is equal to how much better? 2 times of your L2 minus of your L1 divided by your 4. Okay. So from this one, I can calculate the index correction. So E value will be equal to your how much for me? E value will be equal to L2 minus of your L1 divided by 2. Because here it is 2 ones are, this is 2 twos are. And minus of this one is right now L1. So if I simplify this one, and the correction will come out for me how much? E is equals to, this one is L2 minus 3 times of your L1 divided by 2. So this will be the end correction formula for the two cases for comparing 1 and 2. Clear?
Yes, sir.
If you compare 1 and 3, you will get L3 minus 3 times of L2, go on like that. Like say for example, if I give an example here, you see, the end correction of a resonance column is 1 centimeter. Okay. If the shortest wavelength, if the shortest length resonating with a tuning fork, is 15 centimeter. Okay. So the next resonating length will be equal to how much? The next resonating length is how much? Can anyone read the question carefully? With first option is 31 centimeter. Second option is 45 centimeter. Third option is 46 centimeter. And fourth option is 47 centimeter. What is given for me? See in the data. The end correction of the resonance column is E is given for me. E is equals to how much for me? 1 centimeter. If the shortest wavelength with a tuning fork is 15 centimeter, that means shortest means L1. L1 is equals to 15 centimeter. The next resonating will be equal to how much? L2 is equals to how much for me? So if I know the formula right now for me, L1 plus end correction is equals to lambda by 4, isn't it? So now L1 value is right now for me how much? 15 plus 1 is equals to lambda divided by 4. So 16 is equals to lambda divided by 4. Now I need the value of L2. So L2 plus end correction is how much for me? 3 lambda divided by 4. So L2 plus end correction is 1. That is equals to your 3. Lambda by 4 is how much for me? 16. Okay. So it is L2 plus 1 is equals to 16 threes are how much? 48. So L2 will be equal to your 48 minus 1. That will be equal to 47 centimeters. Fourth option will be the answer.
Sir, can you show the above one once?
You can even use this direct shortcut formula. E is equals to L2 minus 3 times of L1. But every time you can't by heart that one. That is the reason I'm writing in the standard form for this one, everyone. This is the shortest. The next means immediately L2 plus E divided by 3 lambda by 4. And he may be using a term right now here. Instead of second resonant length, he may be talking about like fifth resonating or maybe seventh. At a time, it will become for me how much beta? L of your 5 plus E is equals to 5 lambda divided by 4, like that. Got it?
Yes, sir.
Sure. This is NEET 2018 question is given. He has given me the values of your L1 and L2 beta. At room temperature, two successive resonances are being produced. At L1 is equals to 20 centimeter and L2 is equals to your 73 centimeter. Okay, if the frequency of the tuning fork is F is given for me as of here 320 hertz. Okay, the speed of the sound is how much? Can you tell me what is the formula I can use when L1 and L2 are being given? V is equals to how much for me? 2 times of frequency into your L2 minus L1. So V is equals to 2. Frequency is right now for 320 into L2 is 7 minus of your, this is how much? 73. Sorry. This one is 73 centimeters. 73 minus of your 20. So how much it will be better? I'm giving you options. Also, options are 330 meter per second, 339 meter per second, and 350 meter per second, and 300 meter per second. Okay. 2018 NEET got question. L1 is given, L2 is given, frequency is given. He is asking directly frequency of the velocity of the sound. See how much knowledge was being required after studying for one complete year. The student was just required to remember this formula. When data has been given, just substitute and get me the answer. See how much I'm getting? And the answers are in meter per second. So convert that one into meters. So this value will be equal to your 20 into 10 to the power of minus 2. This one is also 73 into 10 to the power of minus
339.
how much? 339 meter per second. Got it?
Yes, sir.
Sure. And how do you calculate beats problems? Beat is nothing but what beta? The waxing and waning of a sound. The waxing and waning of sound. The waxing and waning of your sound is known as beats. Is known as what beta? Beats. Okay, I can say that amplitudes, maximum and minimum amplitude. So the difference between two frequencies is known as what beta? Beat frequency. Beat frequency is represented by delta F. So beat frequency will be equal to your F1 minus of your F. This is known as what for your beat frequency. Okay, so difference between any two frequencies. Here F1 is greater than beta, greater frequency. Okay, now to find the unknown frequency is actually the confusing thing. So you just try to do is you remember this formula, and if it's asking the time, you can calculate the time by using the formula T is equals to your 1 by, because reciprocal of your frequency T is equals to your 1 by F. So if he's asking the time, t will be equal to 1 by delta f, or that is equals to 1 by your f1 minus f2 will give me the time. Okay. So see here, try to remember this trick to calculate the beat problems whenever it has been given. She looks bold, daring, and successful girl. In this one, everything first term you try to remember it. Okay. In this one, the S represents for me your second tuning fork. Second tuning fork. And L represents for me loaded wax. Loaded with your wax L. And B represents me the beat. And D represents for me decrease. S represents for me your second fork. And G represents for me your greater frequency. That means if a second fork is loaded, second fork is loaded with the wax, the beat frequency decreases. Then the greatest frequency will be the frequency of this second fork. Okay, then the greatest frequency, second fork will be the greatest frequency. Am I clear? Am I clear? So what is the condition? If second fork is loaded, right here, we get an idea. If second fork is loaded with wax, second fork is loaded with wax, and is telling in the problem that beat frequency decreases. Then greater frequency will be the frequency of second tuning fork. Second tuning fork. Am I clear with this one? What is the condition? If second fork is loaded with your wax, the second fork is loaded with your wax. What do you mean by fork beta? This will be the tuning fork. This is one and this is your two, like that. It's loaded with your wax and beat frequency is decreasing. Then the greatest frequency will be what? Frequency of second tuning fork. Am I clear? Am I clear? Now reverse of this one is also true beta, isn't it? If the situation changes, the answer will be reverse. The answer will be reverse. That is smaller frequency. Smaller frequency will be the answer. Am I clear? Am I clear?
Yes, sir.
Chalo, write this question. So give me the answer in a second. Actually, I got a tuning fork. There is a tuning fork of frequency 250 hertz. 250 hertz. And it produces 4 beats per second. Okay. When sounded with a second tuning fork. When sounded with a second tuning fork. Now, on loading, the second tuning fork with your wax, the number of beats decreases. The number of your beats is decreasing. Then find the frequency of second tuning fork. Tell me the answer. First read the question. Your tuning fork of frequency how much? 250 hertz. Now this is a tuning fork of frequency output of 250 hertz. Produces how many beats, beta? It is producing 4 beats per second. When sounded with the second tuning fork, on loading the second tuning fork with your wax, the number of beats decreases. Then find the frequency of this one. Frequency of this one is how much? What will be the answer, beta? Frequency of the tuning fork will be equal to how much, beta?
Greater than
Frequency
250.
of the tuning fork will be equal to how much for me? F dash must be equal to tell me the answer, beta. What should be the answer actually? Number of beats are decreasing, then the frequency will be equal to your how much? F dash must be equal to actual frequency is how much better? 250. Answer must be either 2 highest of this one when beats are being given plus 4 is there. So directly I can write here it should be either 254 or it should be equal to your 246 plus or minus na beta beats. But given as per the trick I told you that if the bit frequency is decreasing, isn't it? Then what will be the answer? F dash will be
254.
54 hertz. Clear?
Yes, sir.
What an idea?
Yes, sir.
One more question. A tuning fork of frequency 260 hertz produce 4 beats per second. Okay. When sounded with a second tuning fork. And sounded with a second tuning fork. If the first fork is loaded with wax, the number of beats decreases. Then find the frequency of second tuning fork. Come on, try.
256.
What will be the answer?
256 hertz.
256 hertz, 264 hertz, 260 hertz, and 252 hertz. Okay. So as I told you, beta, first fork is loaded instead of the second. So the answer will be reverse. Isn't it? In
Yes, sir.
the trick, what I told you is that in this one, second tuning fork when it is loaded and beat is decreasing, then the greatest frequency will be the second fork will be the greatest frequency. Now here it has been changing. A tuning fork of frequency 256 produces 4 beats per second when sounded with the second tuning fork. If the first fork is loaded, isn't it? So when the first fork is loaded instead of the second one, so the answer will be reversed. That means the smaller will be the answer, isn't it?
Yes, sir.
Smaller frequency will be the answer. That is, the answer should be either into your first is 256 hertz or it should be 264. As it is, first one is loaded, so bit frequency will be decreasing. The answer means lesser one will be the answer for 256 will be the answer. Got it?
Yes, sir.
అర్థమైందా మరోసారి చెప్పాను right here see first fork is loaded instead of second fork, isn't it? So answer will be reverse. I told you answer will be reverse. Like greatest is the second one, and here it will be the lowest. Okay, the smaller frequency will be the answer for. Am I clear?
Yes, sir.
Chalo.
Yes, sir.
Before I complete the question, you can give me the answer now. A tuning fork. A tuning fork of frequency 410 hertz produces 4 beats per second. Okay, when sounded with a second fork. Okay, on filing the second fork, the number of beats increases. Filing means sanajadam, cutting into two equal parts. So find the frequency of your second fork. Options are 414 hertz. Next one is 406 hertz. Third one is 420 hertz. And fourth one is 400 hertz. Read the question carefully. Now instead of loading, here it is right now for me filing. Filing means you are cutting that body into your two equal parts. Okay.
For not.
See, whenever filing instead of loading is there, the answer should be smaller one, beta. Just remember that one. Okay, I'll write the logic here. Whenever I'm filing, instead of your loading. Okay, so therefore, answer should be smaller. Okay, that is first case. Second case, if the number of bits increases, the number of beats, if I'm saying that increases instead of decreasing, so again the answer what you are writing, again the answer will reverse. That is, what will be the answer now? Answer will be greater one. Okay, now read the question. A tuning fork of frequency 410 hertz produces 4 beats per second. When sounded with the second fork of filing, the second fork, the number of beats is increasing.
For 14 hertz.
Isn't it? Now here it is increasing. I told you that filing instead of loading, the answer should be one what I told you, smaller one. Now second one, the number of bits are increasing instead of decreasing. So again the answer will be what? Reverse. That means the answer will be what? Greater one. Greater one means what will be the answer right now here? 410 plus 4. It will be equal to 414 hertz. Am I clear?
Yes, sir.
అర్థమైందా?
అర్థమైంది సార్.
Sure. Tell me the answer. Let me see how much you understood with this one. A tuning fork A produces 4 beats with tuning fork with your tuning fork B of frequency 256 hertz. Okay. When A is filed, beats are found to increase. Okay. Now tell me, what was its original frequency? What was its original frequency? Good question. Give the option. 252 hertz, 260 hertz, 256 hertz, and 250 hertz. Read the question carefully first. The tuning fork A is producing 4 beats with a tuning fork B of frequency 256. And a second one frequency is given for me. When A is filed, beats are found to increase now. What was the original? See, first fork has an unknown frequency. So smaller frequency 256 might be the answer for me, isn't it? But the first fork is been filed instead of the second one is been loaded. So the answer will be reverse. That means the greater frequency will be the answer for that one, isn't it? The situation is being changed 2 times here, beta. Here first fork is an unknown. Just draw the diagram. This is first one. This is second one. This is B. This is A. This is producing how many beats? 4 beats with a tuning fork of your B. Frequency of your B is how much for me? 256 hertz. If A is filed, the beats are found to increase. What will be the original? See, first fork is unknown. This one is right now for me unknown. Isn't it? So smaller frequency, that is 252 might be the answer here, right? Isn't it? Out of this one,
Yes.
be the answer. But first fork is filed. But first fork is filed. Okay. Instead of second fork. Instead of second fork, which is to be loaded. So the answer will be equal to how much? Reverse.
260.
Greater will be the frequency. So greater frequency will be answer. Am I clear? Actually, if first fork has unknown frequency, so the smaller frequency, that is 252 might be the answer. But first fork is filed instead of the second fork is loaded. So the answer will be just reverse. So the answer will be how much here, right? 460 hertz. Second option will be the answer. Am I clear?
Yes, sir.
See this question. 56 tuning forks are so arranged in series that each fork gives 4 beats per second. Okay, with the previous one. So the frequency of the last fork, is 3 times that of the first. 3 times that of the first. So the frequency of the first fork is want to do it by trick beta. You just need to apply the basics of this one. These are the options given for me. 110, 56, 60, and 52. Now first read the question. How many tuning forks are there, beta? 56 tuning forks are arranged in series. This is 1, this is 2, this is 3. Like that, how many? 56. Okay. So that each is giving how many bits better right now for me? 2. Each is giving how much for me? 4 beats per second. That means if the first one is having frequency f, second one will be your f plus 4. The next one will be equal to how much for me? F plus 2 into 4. Okay, so this is second one. This is your third one. If I'm taking one more tuning fork right now here, which is the fourth one, then frequency for this one will become how much for me? F plus of right now for me 3 into 4. Like that, if I'm going for the 56th one, then it will be your f plus, it will be equal to how much for me? 55 into 4, the previous one. Am I clear? Like so for fifth one it is 3, for third one it is 2, for second one it is your 1. So for 56 it will be f plus 55 into your 4. So this is the last one. Now what is telling in the problem? The frequency of the last fork is 3 times the first one, isn't it? So what is given in the problem for me? What is given in the problem? F plus 55 into 4 is equals to 3 times of the first one. So this will be 2f will be equal to 55 into 4. So f value will be equal to how much? 2 ones are 2 twos are 55 into 2. 55 into 2 will be equal to how much? 110 hertz. Got it?
Yes, sir.
చాలా ఉంది బీట్స్ చెప్పుకోవాలంటే బట్ స్టిల్ I'm not touching the interference here beta, that is constructive and destructive, because we'll try to do that constructive and destructive interference superposition in the wave optics, so it will be easy for you. Okay, sure. And one more very important formula: intensity of the sound wave. Intensity of sound wave is given by the formula 2 pi square f square a square rho into your v. Okay, very important formula bit. Intensity of the sound wave is directly proportional to square of the frequency, square of the amplitude, directly proportional to density, and directly proportional to the speed of the sound, that is nothing but v. So intensity is directly proportional to your a square. So I is equals to how much for me? K into your a square. This is also a very important formula which you need to remember. Intensity is directly proportional to this one. And one more important formula, that is about your sound level. Formula gurtunda? Sound level, how do you calculate it beta? Beta is equals to 10 log base 10 I divided by I naught. Okay, unit will be equal to how much? Decibel. Okay, so sound level in your decibel will be equal to how much? 10 log of your I divided by I naught. Got it? What is the value of I naught beta? Constant value, you need to remember, it will not be given. 10 power minus 12 watt per meter square. Okay, if it's asking the change in sound level, SL, then at a time will be beta 2 minus beta 1 will be equal to, this will be 10 into, this will be equal to log I1 divided by I2. That will give me the answer. Clear? Let me give one small example. Say for example, a point source is emitting sound in all directions. Intensity is directly proportional to square of the amplitude beta. So it is square of your, what do you call that one? Amplitude. Now a point source is emitting the sound in your all directions. The ratio of distance of 2 points from point source, from the point source, where the difference of loudness level is 3 decibel is on. In the bracket log base 10 is equal of 2 is equals to 0.3. That is given for me. Sure, try to do it. I'll give the options. First option is 1 by 2. Second option is 1 by root 2. Third option is 1 by 4. And fourth option is 2 by 3. First read the question better. A point source means this one. It is giving the light at a certain distance. Intensity is directly proportional to P divided by A area. So it is proportional to your area of this one will be 4 pi into r square because the point source will give these sound waves in the spherical part. So it will be your 4 pi into your r square. Now intensity level formula beta. What is an intensity level? Delta beta change in is given for me. That is a 10 log of your I1 divided by I2. So change in intensity is given as of your how much for me? 3 decibel. That is equals to 10 into log. This will be R2 divided by R1 whole square because intensity is inversely proportional to square of the distance between them. Isn't it? So this will be 3 by 10 means it will be 0.3. That is equals to log of your R2 by your R1 is your R2 divided by R1 whole square. So this will become for me log base 10 to the 2. Isn't it? 3 value is already given for me in the problem. No? Base 2 will be equal to log of your R2 divided by R1 whole square. So log to the base 10 value if it is getting cancelled. So this value will be equal to R2 divided by R1 will be equal to how much better? Root 2. So R1 by R2 will be equal to how much value? 1 by root 2. So option will be equal to second. Okay. The point source is emitting the sound in all directions. The ratio of the distance of the 2 point sources. That means if this is your R1 for the point source 1, there is your another point source S2. For this one, this will be distance R2. So intensity is equals to power divided by area. So area of this one is in the spherical part, inversely proportional to R square. So I is inversely proportional to R square. Intensity formula is how much for me, better? I is equals to delta B change when it is been given. So it is delta beta is equals to 10 log I1 by I2. So intensity is inversely proportional to R square. So in the place of I1 by I2, I took the value of R2 by R1 and simplify. We'll be getting the answer for that. Clear? Sure. So this much of knowledge is more than enough to do some random questions which comes in your sound levels. Okay now? Today is 19. Okay. Sure. Tomorrow morning there will be no grand test beta. I'll let you know Sunday or right. In some other timings, we'll try to discuss the paper. Okay. Sure.
Okay, sir.